Welcome to a lesson with Dr. Pell. Let's take a look at an example of a sequence. What if we were looking at this sequence? All right. Let's see. All right, something like this, and it just keeps on going in this pattern. Um, does this sequence have a limit, and what is its limit? Well, we can kind of think about this from term to term. What's happening? This term is quite literally square root of 1 plus what came before it, and so is this guy. So we kind of have a nice format for recursion here. So this is the recursive formula, and you could even say perhaps that we're starting, maybe we start at z, okay, so maybe this recursion we start, maybe this is like a1 is equal to this guy, so then a2 would be square root of 1 plus that guy. Okay, so let's go from there and see what we can do. Now, if we take a limit of both sides, they both go to the same limit, and then squaring, then we have L squared minus L minus 1 is equal to 0. Complete the square, we get L minus a half squared, and that's going to be equal to 5/4. Because okay, and then square rooting, say we get 5/4 plus or minus half. Okay, so we get some options here, which is okay, that's the whole square root, which is the same thing as 1 plus or minus root 5/2. Okay, so L could be either the plus or the minus. Now, this sequence, just glancing at it, looks like it's increasing from 1, so it's probably going to be the positive one, because the negative one actually gives us a negative number overall, because square root of 5 is bigger than 1. So we'd like this to be the limit. Now, does the limit even exist, and is that the limit? We can see that via a picture here. So we can take a look. Let's just write that. Okay. Take a look at graphing this, where this is like your y and that's like your x. It looks something like this: the square root graph shifted 1 to the left. Okay, and then it's going to intersect this somewhere. In fact, the intersection where this intersects is so if you were to draw this completely out, it intersects in 2 places. One is actually the 1 minus square root of 5/2, and the other one is 1 plus square root of 5/2. Because essentially what we did in putting L here is the same thing as like putting an X here and X here, which is like finding the intersection of this graph with the Y here and Y equals X and solving. So really this calculation computed those 2 points. Now, if we start at A1 is 1, okay, so that's less than this, so this is over here somewhere, okay, and we come up here, so A1 is 1, and we come up to see what the next guy is, we're here. And then we go over to see where we're going to go next and plug it in and so forth, and it looks like we're increasing to that stabilizing point. So indeed, we do converge to that point, so that the limit is this, 1 plus root 5/2. Thanks for watching.